How's it going, guys and girls? Today we are looking at 2.4 rates of change and tangent lines. This is calculus. Okay? This is what calculus is. It's finding the rates of change and the tangent lines given a curve or given an equation. Aren't you as excited as I am? Pure elation. Okay? First, let's have a quick talk. Average rate of change is going to be the quantity over a period of time is the amount of change divided by the time it takes. Your total amount of change that happened divided by how much time it takes gives you the average change per a specific time. Okay? The reason why this is important, if I have a curve, right? The curve, let's say, is your money over time, and you want to know how much it's changing at a given time. So if you should sell your stock or buy more of it. Okay. So that's actually going to be a slope of a secant line to a curve. What does that mean? Well, let's take a gander. Let's find average rate of change first. Of course, examples are noteworthy. Just so you know, if you're finding the rate of change of A from the interval A to B, that's the same as f of B minus f of A all over B minus A, which is also known as your y1 minus y2 all over x1 minus x2 because it's slope. Okay? So first thing I gotta do is plug negative 2 into this equation. When you do that, you get 2 times negative 2 squared minus 3 times negative 2 plus a 7, which I actually already did in my notebook here, which according to my calculations, which are probably wrong, and it's 21. And then we plug our 4 into this beast, and we do our 2 times 4 squared minus 3 times 4 plus 7, which is 27. So we go 27 minus our 21 all over our 4 minus our negative 2, which is 6 over 6, which is 1. Our average rate of change is 1. Means nothing right now, but it will eventually. Okay. So again, you're just finding your x, y's, find your slope. Nothing too earth-shattering here. Take your endpoints, plug them in the equation, subtract them, subtract your original points. You're done. Here's a good question. I'll even blow it up. That's a joke. What they're looking for is the secant line. Okay? Line accurately draw you the point 1, 2, and 2, 4, right? Don't worry about the other ones. We're just going to make this one and draw a secant line. So you go over 1 up 2. Okay? And then we go over 2 up 4. Okay? And you draw a line in between them. That's your secant line that goes in between those 2 points. What's the slope? It's a secant line. Now you could go through and say, well, it's your f of 2, or you could do your good old-fashioned slope, which is 4 minus 2, your change in y's, all over your change in x's. Okay? So you get 2. So this line has a slope of 2 that passes through both those two. Right, that's what a secant line is, guys. It's something that passes through and hits both the points in that graph. This has not been a good video so far. Does my hair look good? You got my movie for it. Let's talk about the tangent to a curve. This is the most important part of all this mess. This is calculus. This is calculus. What you want to do we want to define the rate at which the value of a function y equals f of x is changing, okay, with respect to x with any value. So at any point we pick on that curve, we know exactly the rate of change that's occurring at that point, okay? The problem with that is that we'll only be given 1 point. If we have 2 points, we can just find the slope. If given 1 point, there's no equation for a slope that just has 1 point, okay? Let's look at our problem. We have 1 point, and we want to find the slope of this tangent. And you might be saying, well, you can just graph it, and then you can just take a ruler and or a protractor. No, we have to be able to do this for any given point on that graph. This wasn't noteworthy, it's just what you need to know. So how we do this? You start with a secant that goes through PQ, and then you keep bringing it down to where it needs to be. And once you get that slope of the curve at that point, that's your tangent. Okay? Some theoretical stuff. I'm going to skip ahead. This is the equation you are going to be using a lot in calculus. It is the slope of a curve at a given point, a f of a, is your limit as h approaches 0 of f of a plus h minus f of a, provided the limit exists, and that is the tangent line to the curve has that slope. Okay? Definitely noteworthy. Okay? So go and write it. Ponder this while you do it. Take a look at this picture. We have a function. Okay? We have our point that we want to find the tangent to, right? And what we're doing is we're picking some other arbitrary point here, and we're adding h to our a, okay? And now what we need to do to find that slope is move h closer and closer to 0, because we're picking a point that's infinitesimally small close to that point. And what we do is we end up getting the exact value of the actual tangent. I know a lot of you guys are probably scratching your head saying, why am I in this class? What's going on? It's a lot easier than what you think. You're just taking your graph, your arbitrary point, moving that point closer and closer to it until you get the actual slope of the tangent. Okay? Doesn't that sound like fun? It is. It is. Well, anyway, some things to keep in mind. The slope of y equals f of x at x equals a. The slope of the tangent, or these are smart ways to say it. The slope of the tangent to y equals f of x at x equals a. The instantaneous rate of change of f of x with respect to x at x equals a. There's another one. There's not. These are all saying the exact same thing, because the tangent is your instantaneous rate of change, which is your slope at that given point. I'm way too excited for this. Let's do it. So we're given the function x squared plus 2 at x equals -1. We want to find the slope of the curve, the equation of the tangent line, and then draw the graph of the curve and the tangent line in the same viewing window. I'm on pause to check for time. Okay, so no one told me my hair looked disheveled. I can't see myself until I pause it. Thank you. So let's start this thing. So my equation is x squared plus 2, right? And we're going to be at x equals -1. Okay? So we're using this equation. Your limit as x approaches 0 of your f of a plus h minus f of a all over h, right? But we actually have a point. Think about it this way. This is our a, right? So we're using point -1, and then you use f of a, right? F of -1, we plug it into the function, right? Saying right a lot. So -1 squared plus 2 is 3. So that's our a f of a. Okay, and we got that from this x equals -1. So let's plug some stuff into this equation. So we're actually doing f of -1 plus h minus our f of a is just 3. Okay? All over h. Right? Well, let's expand out that f of -1 plus h. Okay? That's equal to -1 plus h squared plus 2. Because we're plugging it into this equation. Wherever we see an x, we're plugging -1 plus h. When I factor that out, you get 1 minus 2h plus h squared plus 2. FOIL, guys. -1 times -1 is 1. -1 times h is -h. Negative h, or -1 times h again, is h squared. Okay? You should have that stuff in your memory banks by now. So if I want to rewrite this, by the way, 1 plus 2 is 3, right? If I want to rewrite this, I can write this as 3 minus 2h plus h squared, right? Minus 3 all over h, right? So when I look at my 3's cancel, okay? I can factor this top and an h out of it, so I get h times -2 plus h all over h. This is going to happen a lot. Now what happens to my h's? They're gone. Capuzzo. Gonzo. So really, this whole mess we started off is the same thing as finding the limit as x approach, or not x. Not x. Not x. Not x. Not x. Did I say x? H. H. As h approaches 0 of -2 plus h. Now think about this. What's this limit? What happens as h goes to 0? It means nothing. It's -2. That's our answer. That's the slope of the tangent at that point, -1. That's your differential used to differential equations. You just did calculus. You did rocket science. Nice job. I got pause. Alright, so we just did part A, right? We just did find the slope of the curve. Now we have to find the equation for that tangent line, right? Well, we have a slope. Our slope is -2. Okay? We also have a point. Point is -1, 3, because that's on the graph, right? So we have a slope and a point. So we use our point slope form. I did something really wrong. So let's try this again. Remember this equation for line. Y minus y1 equals your slope times x minus x1, right? So we plug in our pieces. Our slope was -2. X minus your x coordinate. Y minus your y, right? You do have to get y by itself, guys. Why? Because I said so. So you get -2x. This becomes a +1, so it's -2. Add that 3 to both sides, so it gets rid of that, right? And then, so on this side you get -2x plus 1. Now we have to graph it. Now, since this, our original graph was x squared plus 2, I don't know, it's kind of like this, right? Okay. So now when I draw my other graph, I go up 1, my slope's negative, so it's up 2 over 1. Oh, look at this, it's gonna work. It's gonna work. That's my slope of the tangent at my given point, -1, 3. Okay, and there we go. I did calculus, rocket science. I'm a genius. What I think I'm going to do with this section, guys, since I'm going to break it up into multiple parts, is this video is not going to cover everything in 2-4. I'm going to do the rest of that in bits and pieces and probably do some more examples with you. And that way just you get a better feel for it, and you won't have 3 days in between watching the video and homework. So this will end it today. Enjoy. I'm sure there'll be questions whenever we have class again.